Alright, this is problem number 47 in section 4.8. Again, this is an ACT type question. This is the type of high level question you're going to see on that test. So I'll walk you through it. 47. Find the length of the sides of a regular pentagon that's inscribed in a circle. Okay, so here is a pentagon inscribed in a circle. We're supposed to find a length of that pentagon inscribed in this circle. And it's a regular pentagon, which means all of these sides are equal. Okay, that's what regular means. So the easiest way to do this is to split this pentagon up into triangles. As we're studying triangles, we're going to use trigonometry to solve this. So let's see if we can make some triangles here. Okay, and then I'm just going to focus, first thing I'm going to do is find the angles in the center here. Okay, we know that a circle is 360 degrees. Well, I just divided this circle into 5 equal sections. So to find out what these interior angles are, I'm going to take 360 divided by 5, which is 72, which is 72 degrees. Okay, the next thing I'm going to do, and maybe you'll understand why here in a second, is I'm going to cut each of these triangles in half. So then I can turn them into right triangles. And I'm going to draw that triangle down below here. Okay, so it's got a vertical line, it's got a horizontal line, and then the base is this black line up here. You see, this is the triangle I drew right here. Okay, and then so this is a right angle, and we know a little bit about this. Okay, we know the blue side is a radius of the circle, and it says in the problem that the radius is 25 inches. Okay, we also know it's a right triangle because I drew it that way specifically. I cut these two triangles in half. And I did that with a red line that was perpendicular to the black line. Okay, so we also know something about the angles of this thing. Since the angle on each of these bigger triangles has 72 degrees as its angle, and I already told you that I cut this angle in half over here. Well, if I cut 72 in half, that means this angle is 36. So what do we have here? We have two pieces of information in a right triangle. Anytime we have two pieces of information in a right triangle, we can find another side or another angle. We can find everything we want to about this right triangle. So we're going to use this to find the base. Okay, I'm going to call it y, but maybe you've noticed that y up here is always going to be half of x. So once I find y, I'm going to take 2 times y, and that will be the side of my regular pentagon inscribed in this circle. So how do I find y? Well, using this angle up here, y would be opposite. This length would be the hypotenuse. So again, we're going to use sine. So it would be sine of 36 equals y over 25. So 25 sine of 36. And then if I multiply this all by 2, this will turn it into the x, which is what we're looking for because I know 2 times y equals x. So putting this into the calculator, 2 times 25 sine 36. My answer is, I was in radians, no wonder it didn't look right. My answer is 29.4. Let's go with that, 29.4. And does this make sense? Well, let's look back at the problem. The radius is 25. Okay, this side we just found is 29.4. So yes, that does make sense to me. There's our answer. Hope this helped.